Hello everybody. Our goal for today is to use this video to introduce you to some basic metrics for network analysis. To begin, we're going to start with a basic question. How large is your network? Let's start just by brainstorming a little bit. Here are two networks that I have on the slides. I want you to take a second, pause the video, look at these two networks, and think about how they're different. Okay, so some of you probably have some descriptions. We might notice that with network 1, there appear to be not only more people or more nodes in our network, but also more edges or connections between those two nodes in network 1. So network 1 both has more nodes and more edges than network 2. Here's another pair, network 1 and network 2. If you want to pause the video at this point and take another look, feel free. What you may notice in these two pairs of networks is that both of them have the same number of nodes. However, network 2 seems to have fewer number of edges. Right? So network 1 we might still side with as being the bigger network. Even though they have the same number of nodes, they have a different number of edges. Here's our last informal example, comparing network 1 and network 2. If we look at these, we notice that network 1 has 6 edges but 4 nodes, whereas network 2 only has 4 edges and 5 nodes. So on the one hand, network 1 has fewer nodes, so you may be able to make an argument for network 2 being larger. But there seems to be more edges in network 1 than in network 2, so you could try to make an argument for network 1 being larger. Measuring how large a network is a complicated question. And complicated questions deserve a complicated answer. So let's consider kind of a silly example, and we'll use the analogy to make a case for why we need different metrics for different networks. Suppose we wanted to ask which one of these three animals is the largest. I think most of our gut instincts would be to say that the hippo is the largest. After all, the hippo weighs the most. However, some people might be interested in arm span. So what's the length from the end of one arm to the end of the other, in which case it's likely that the eagle is going to have the largest arm span of these three animals. So in that sense, that would be the largest animal. What if you're looking at the length of the animal from tail to nose? In that case, your snake is going to be the largest animal. So the idea here is that when you're judging how large a particular animal is, there's many different criteria that you could use depending on what your interest is. Similarly, there are many criteria by which we can measure the magnitude of a network. So in summary, networks, like animals, have many characteristics that may be important for our studies. And our basic idea moving forward is we're going to need different types of network metrics to communicate these different characteristics of our networks. We've already informally talked about two different network metrics. The first is the order. This is the total number of nodes that we find inside of a network. So here we're focusing on the actual people if we're considering a social network. In our case, we have 5 different nodes in this network, so we would say that the order of our network is 5. We can also shift gears and focus instead on the number of edges in the network. This many texts refer to as the size of the network. Here we simply count up the total number of edges. We can see that there are 6 edges in this particular network, so the size of this network would be considered 6. Now we can go back to our last comparative example where we had network 1 and network 2, and it was sort of ambiguous as to which one was quote-unquote larger. Now we can speak in a little bit more specificity by using 2 of our network metrics. So for example, in terms of order, network 1 is the smaller network. This has fewer nodes than network 2. And another way of communicating this would be to say the order of network 1 is smaller than the order of network 2. In terms of actual edges, network 1 seems larger. It has more edges. Its size is larger than the size of network 2. If we restrict our attention to social networks, where nodes are people and say edges are friendships, then the order simply counts up the total number of people involved inside of the network, and the size counts up the total number of friendships involved. So we could think of something like a subway, where there might be a lot of people inside of a subway car, but not a lot of people know each other. We would describe this type of situation as a network with a high order but a very low size. If you think of something more like a small party, where maybe there aren't too many people attending, but everybody is friends with everyone else, this would be a network with a small order and a very high size. Let's consider one more important metric. This time we want to focus on the question, how connected is your network? To explore this, I want to use an example. Many of you will be familiar with what a telephone tree does. The idea is we want to disseminate a lot of information, but we don't want to put too much of the responsibility on any one person for making sure the information gets to everybody in the network. So here's the way you break up the work. Each person only calls two other people. So the first person to be told the news calls two others. Each of those people calls two others. Each of those people calls two others. So in 3 quick iterations of this telephone tree, we've managed to contact 15 different people. Now, what makes telephone trees effective is the fact that they are connected. Here's what happens. Suppose Phil forgets to call one of his people. So this edge we're going to remove. If you think about the top node, or the top person getting the information and spreading it with his or her phone calls, what happens is when we remove that edge, we make the telephone tree no longer connected. And you'll notice that there's 3 people in this particular network that never hear the news. By failing to make that phone call, Phil breaks this telephone tree into 2 different connected pieces. We have the connected piece in red and the connected piece in blue. Let's consider another example. Suppose you create a network of your friends, right? You're not included in this network, but each one of your friends appears as a node, and if your friends are friends with each other, we draw a line in between them. So what will probably happen is you should be able to separate this network into different connected pieces. For example, one connected piece might be your high school friends, another connected piece might be your college friends. Now in reality, it may be much more complicated than this, but this sort of demonstrates the idea. Oftentimes networks will break into what we call connected components. Right? Each one of these is considered a connected component. The metric that's associated to counting or establishing this connectivity is essentially just counting the number of connected components in the network that you're interested in. So in this case, we have 2 connected components. In the book Connected by Christakis and Fowler, they have this really great analogy that kind of helps you visualize what your connected components are going to be. The idea is to think about your network as being just each node as a button, and if 2 nodes have an edge in between them, you connect them with yarn. So then the idea is, if you had a network and you wanted to start pulling apart the connected pieces and determining how many connected components you have in your network, you could just pick a button and lift it, and the connected component, by lifting that button, would come away, and then you could see what you're left over with. Here's sort of a visualization of this. Suppose this is my network. I can grab a button and I can pull it, and all of the other buttons, all the other nodes that are in that connected component will get dragged with it off to the side. I can grab another button. All of its connected pieces will also get dragged with it via that string, via that yarn connecting it. And now I can see that in this case I have 3 connected components for this particular network. This won't always be visually obvious, so oftentimes reporting this metric, the number of connected components, is an important part of reporting the information for your network. So in review, we've covered 3 basic metrics for our networks: the order, which is the number of nodes inside of your network; the size, which is the number of edges; and then finally the number of connected components. There are many more metrics for networks, and we're going to explore those in further videos. Thank you.